All right, let's open up to page 89. All right, so yesterday we were looking at absolute value functions and how we can rewrite them as piecewise functions. Erica, can you do me a favor and close the door? Okay. We're going to take a look at two more problems today, but these ones are going to be a little step up, okay, because if you take a look at the second one, notice how it's a fraction, okay, so we're going to kind of increase the difficulty a little bit, and B, we are no longer going to use the little charts that we had yesterday. You can reference them, okay, so you can flip your paper back and forth if you have to, but I just want you to be aware that this is what a particular question might look like on a quiz or a test, okay? So yesterday, the chart was useful for us to start to think about what we should be doing, what we should be looking for, but eventually we're going to be familiar with those things, okay? So we're going to try to not use the chart today, but you can reference it if you have to. So looking at the first one, we're going to add these two absolute values together. We're going to try to write it as a piecewise function, okay, individual equations, and then we'll graph those individual equations to see what this would look like as a picture, okay, without using a calculator. Now, I know we have a calculator, so we'll check to see how accurate we are, but we're going to try to do it without one first. Okay, so can we think about yesterday, okay, our little process, our little chart, and where we should start to look at this equation? What would be useful to identify first? If you have to take a look at what we did yesterday, that's fine. Go ahead, Caitlin. The vertex. So can we figure out, now we have two absolute values, so we're probably going to have two vertices. Okay, so can we figure out where those are? You want to keep going, Caitlin? Yeah. Okay, so if you set the first one equal to 0, we would solve for x and get -2. If we were to set the other one equal to 0 and solve for x, we would get 3/2, okay, or 1.5. So graphically, these are the x coordinates where we have a vertex or kind of one of those sharp points. So we know something's going on here at -2 and something's going on here at 1.5. Okay, we just don't know where it is, but we know where it is on the x-axis. We just don't know the height. So with these numbers, we're going to go ahead and draw a number line. And we're going to label the values of -2 and 1.5 because we know that's where a vertex is. In other words, that's where one line of the absolute value ends and the other line of the absolute value begins. Okay, because we have that kind of V shape. We have two lines. Where can we go from there? So we found our kind of special values. How can we now develop our little number line or sign chart? Can we look back from yesterday? You're on a roll, ma'am. Okay, so we have, if you look at your number line, you have three sections. You have the left-hand side, the middle piece, and then the right-hand side. So we're going to rewrite the original equation in each spot, okay, so 3 times, but instead of bars, we're going to use parentheses, okay, because eventually we're going to distribute something in. And we can distribute through parentheses, but not bars. All right, so let's write x plus 2 in parentheses, and then plus 2x minus 3 in parentheses. I apologize if you don't have enough space. Maybe you got to write a little smaller or stack them, kind of like I did. But we got to write it 3 times. we doing okay so far? Coming back from yesterday? A little? Okay. Where can we go from there? Good, Lainey? Okay, so on this first interval, pick any number you want between negative infinity and negative 2. What do we feel like today? Negative what? Negative 3. Okay, so we're going to take that value, whatever you want to pick, and we're going to plug it into the parentheses, okay, one at a time. So in our first parenthesis, if we did negative 3 plus 2, would our answer be positive or negative? I'm not worried about the number, I'm worried about the sign. Yeah, negative. So we're going to put a little negative in front of that parenthesis group. We have another one to test. So if we plug in negative 3 and for this x, we'll get negative 6 minus 3, and that's negative as well. Okay, so we'll throw a negative in front of that one. We're going to repeat the process for the other intervals. So our next interval is from vertex to vertex, so pick something between negative 2 and 1.5. 0 I think would be pretty easy, yep. So if we plug in 0 to the first parenthesis, 0 plus 2 is 2, so that's positive. And then in the next parenthesis, 0 minus 3 is negative. Negative 3, so we'll throw in the negative. All right, our last interval, pick something you want between 1.5 and infinity. What are we feeling? 2? Deal. All right, 2 plus 2, 4, that's positive. 4 minus 3, still positive. So now that we know how each individual piece is acting, okay, if it's positive or negative. Hello? Hi. That's fine. Thank you. Yep. Bye. Okay. So now that we know how each individual parenthesis is acting, okay, whether if it's positive or negative, meaning going up or going down, we're going to combine them together, because notice how we are adding these pieces together. So we're going to simplify, combine some like terms, see what we get. The first parenthesis, if we distribute in that negative, we'll get negative x minus 2. And then the other parenthesis, if we distribute in the negative, negative 2x plus 3. So combining those two results together, we get negative 3x plus 1. So on this particular interval, negative infinity to negative 2, this is what the graph is going to look like. Okay, specifically this line. We're going to repeat the process. So our next interval, if we distribute in a positive, that's not going to change anything. But then we got to distribute in the negative to the next group. Combining like terms, we'll get negative x plus 5. The last interval, they're all pluses, so everything will stay the same. And combining like terms, we'll get 3x minus 1. So this graph, okay, of these two absolute values being added together is really the graph of these three separate lines. Okay, and we're going to use those lines to help us get a picture of it. So combining, bless you, combining all this information together, we're going to write our piecewise function. So our results are 3 lines. We'll write those in as our equations. And then our piecewise function also needs little domains or constraints. So we said this first line shows up on the interval from negative infinity to negative 2. Those are all x's that are less than negative 2. Can I include negative 2? Can I put a little bar there? What do you think? Why? It's a V shape, okay? And we said that this -2 was a vertex, right? A sharp point. And we know on a V-shaped graph, there's an actual filled-in circle there. Okay, it's a vertex, it's a sharp point, it's a point that exists on the graph. So we can include it. The next equation shows up between the vertices. So we can write that using our inequalities between -2 and 1.5. And then the last one would be greater than or equal to 1.5. All right, so without a calculator, let's go ahead and graph these 3 lines. It looks like our barriers are at -2 and 1.5. Let's see, so our first line, if we plug in -2, we'll get 6 plus 1, which is 7. So we can throw in that closed circle. And then to get another point, maybe we can use the slope, but we got to work backwards so we're in the correct region of our graph. So up 3, left 1. All right, so there's our first line. Let's try the second line. If we plug in -2, we'll get 7. Okay, so we have the same closed circle as before. If we plug in the 1.5, okay, on the other barrier, -1.5 plus 5 would be 3.5. Okay, so closed circle right there. So we know this graph should be a straight line. We can simply play connect the dots. All right, so our last line, if we plug in 1.5, 3 times 1.5 would be 4.5, minus 1 is 3.5. So we're on the same closed circle. We can use the slope to help us get another point. So up 3 over 1, up 3 over 1. You can keep going if you want to. So there's our graph of our 2 absolute values being added together. It's still kind of a V shape where we have those vertices, those sharp points, but it's not exactly a V. Okay, when you're adding absolute values together, it can kind of distort the shapes of the graphs because you don't just have one of them. Okay, let's see how accurate we were. So on our calculator, we'll practice from yesterday. Let's graph it. So hit the y equals button. If there's anything in there, go ahead and clear it out. Do we remember the buttons we pressed to get an absolute value? How we find it? Yeah? Math. Over to number. The first one would be ABS. Okay, so selecting that will bring up the bars. Let's type in x plus 2. We have to arrow over because we're going to have to add in another absolute value. So repeat the process to get the bars. And then we'll type in 2x minus 3. Okay. Before we hit graph, let's make sure our window is good. So let's see, our graph goes from -7 to 9, counting by ones, and then -3 to 13, counting by ones. We'll go ahead and hit graph. Say we did pretty good, right? Matches. So it looks like we're doing something right. All right, just for practice, can we figure out the domain and range of this graph? If you're trace it left to right, low to high, what are these values that we can include? Yes, ma'am?
Negative infinity to positive infinity.
Perfect. You want to do the range too?
3.5 in bracket.
Okay.
Infinity.
Perfect. We're getting really good with those. All right. Domain left to right, range low to high. Was that a good review from yesterday? Okay, we didn't have any of those guiding boxes or steps. Okay, maybe you had to reference them. Okay, but we need to be familiar with kind of this process, this analysis. We're going to step it up a bit and try this next one. Okay, so this time we're dealing with a fraction, not just two absolute values added or being subtracted together. Okay, it's a different type of function now. But the process is still very much the same. Okay, can we figure out where a vertex is on our graph? Where kind of one line ends, the next one begins. Think about how we got -2 and 1.5 from the previous examples, if that helps. Can we label a vertex? Yeah? 5. Okay, what makes the absolute value equal 0? Okay, so there's our vertex. Now let me ask you this. Is there another x value that would be interesting to identify or know? What do you think, Lainey?
-3, because then there would be no solution.
There'd be no solution. Notice how -3 makes the bottom 0, right? And we've discussed previously how you can't divide by 0. That makes it undefined. So the x value of 5 is a vertex, but the x value of -3 we'll say is undefined. So what's a little bit different is we're actually going to use these two values on our number line. Okay, because there's special x values that we want to be aware of. Where are we undefined and where do we have a vertex? So this is something new because we've never had an undefined example before. So we're going to do a nice big number line and we'll type in -3, not type, we'll write in -3 and 5. Now what I'm going to do on my number line, just as a reminder to me that -3 is undefined, okay, it's an x value that does not work, bless you, I'm going to put a little slash through it. Because I know I cannot plug in that number. Okay, we cannot include it at all. We can include 5 though, because we know that's a vertex. -3, not so much. All right, so let's fill in our number line. We have 3 spaces, so we're going to rewrite the original equation 3 times, 1 in each spot, and instead of bars, we're going to throw in parentheses. So we're going to test to see how this equation is behaving on each one of these intervals. Okay, is it negative, is it positive? Okay, meaning is it going up, is it going down? How is it acting? So on the first interval, pick anything you want between -infinity and -3. What are we feeling? -4. All right, now we only plug that into the parenthesis part, because we need to determine if we put a positive or negative sign out front. So just in the parentheses, if you were to plug in -4, we'd end up with 5 plus 4, which would be 9, so that's a positive number. Okay, we don't plug it in everywhere, it's just for the parenthesis value. What about the next interval, something between -3 and 5? 0, good. 5 minus 0, it's 5, so we'll leave it positive. What about our last interval? Something between 5 and infinity? 6. Okay. 5 minus 6? Negative. All right. So let's simplify and see what we get. Our first equation here, if we distribute in a positive, nothing's going to change. And if we combine some like terms up top, we'll get -x minus 3. So far we have -x minus 3 over x plus 3. Are we done? Can we keep going? Can we simplify it further? Can I see x's and 3's. Can I just cancel those things out? What do you think, Hadley?
No, because you can only do that when you're multiplying.
When you're multiplying. Okay, so we cannot simply cancel the 3's and cancel the x's because we're adding and subtracting. But can we turn, for instance, the numerator, instead of subtracting these things together, can we kind of turn it into multiplication to maybe cancel something? Is there anything we can factor or pull out? Yeah.
Would you take out -1?
Okay.
And make it x plus 3, like, in parentheses of negative?
There we go. Notice how this is multiplication now, right? We have a -1 times something. So if we take out a negative, notice how the x plus 3 quantity up top matches the x plus 3 quantity down below. So those now can cancel. They match perfectly. So we're left with just the -1 that we GC after factored out. So on the left-hand side, we essentially have a line of -1, okay, horizontal line. Let's try the middle section. So if we distribute in a positive, nothing's going to change. What's going to happen if we try to simplify that fraction? It's going to be the same thing, right? Okay, notice how they match. So we have -1 in the first interval, but also in the second. All right, the third one is going to be a little different because notice how we're distributing in a negative. So the signs would change. And combining like terms, we'll get x minus 13 over x plus 3. Now we have to leave it like that because again we're adding and subtracting within the fraction. We can't just choose what goes away. So we're going to try to combine all this information together and write our piecewise function. I ran out of room, so I'm going to write it at the bottom. Now if you take a look at our results, notice how we really only had 2 equations. Even though we had 3 intervals, okay, we had 2 results. So we're going to write -1 and x minus 13 over x plus 3. Okay, those were our 2 equations. Can we determine the domains or the constraints for those 2 equations? Where did we have this equation of -1 showing up within our number line? It showed up on the left and the right. So can we write an inequality stating where this happened? I mean on the left and the middle rather. What do you think, Hadley?
Could you make it less than or equal to 5?
All right, x is less than or equal to 5 because notice how at 5 it ended and everything less than that we said was -1. Okay, this is going to be a little tricky though. Notice how we had a slash on -3. We said that was an undefined location. So what's happening here is we're actually going to have another constraint. Maybe you've never seen this before. So we're basically stating that this equation of -1 shows up when the x values are less than or equal to 5, but also x cannot equal -3. We kind of have to merge the 2 pieces together. Do we see that? Do we understand that? Yeah.
Are you able to write them separately if you want?
You mean like if you want to write -1 twice
Yeah.
and do them separately? That's okay. Yeah. The third piece shows up from 5 and values greater than that. So we'll do x is greater than or equal to 5. Okay, a little tricky for the first one because we had to skip over that -3. Now we're not going to graph this by hand because notice how our equation here was not a simple line like all the other ones were. It's a complicated fraction. But I do want to graph this on the calculator just to see what it might look like. Okay, just an interesting picture. So on the calculator, we'll go to y equals, clear out the last example, and we're going to type in the original function. Now, since it's a fraction, we have to be careful on how we do that. Okay, your calculator is very picky on how you type things in. It needs to know exactly what you want it to do. So since we're going to type in a fraction, you have to tell your calculator you want all of the numerator, okay, all of the top stuff, divided by all of the bottom stuff. So So we're going to have to use parentheses to denote that idea. Okay, all of the top divided by all of the bottom. Yeah.
If you push alpha y equals, you can just make an actual fraction.
Alpha.
Alpha and then y equals. And then just enter.
Numerator over denominator. You could do that. I am not, to be honest, I'm not too familiar with the F1, F2, F3, those commands. Okay, I learned, this command wasn't available when I was in high school. Like, it's a different operating system. So this is how I had to do it back then. But if you are familiar with that, okay, can you repeat that process for us again?
Alpha y equals.
Alpha y equals.
Enter.
So it's numerator over denominator, and you'll get that. Okay, well, let's do it. So in the little boxes, first of all, does everyone's calculator look like this? Do you have those boxes? Okay, because some calculators have a different operating system, and they might not look like that. Okay, let's go ahead and type in an absolute value. So we can go to math over to number ABS. Thank you. And we'll type in 5 minus x. You have to arrow over to type in the minus 8. And then to get to the next box, just arrow down, and we'll type in x plus 3. Looks good. I am not sure what this graph looks like, and they don't really give us a table on our notes to help us with the window. So for right now, we'll just keep the window the same, okay, from the previous example, and we'll see if we have to change it. All right, go ahead and hit graph. All right, so take a look at it. It's kind of small there, but notice how we have a flat line at -1, just like we said we should. And then at 5, that's where a vertex is because it starts to change. So the right-hand side is part of the graph of this fraction, okay, that we're barely seeing. Now here's something that's interesting. Didn't we say we could not include the x value of -3 because it would be undefined? Doesn't it look like there's a closed circle there? Like there's an actual graph? Yeah? Okay, but we said there shouldn't be anything there. Check this out. If you hit trace, remember that brings up the little spider, and you type in -3, notice how there's no y value associated with that x spot. So your calculator is not physically capable of graphing those open circles. And the reason is the open circle is so small because it's only supposed to be at one point. Okay, it's called infinitesimally, if I can even say that word, infinitely small, because it's like a pinhead. So you can't see it there. But if you type it in to check it, notice how there's nothing there. So there is a hole, even though you can't see it. That's what's a little tricky. Okay, I mean, you can test other values like -6 and 4. Okay, notice how we start to get other values. But when you type in -3, there's nothing there. Okay, there's a hole. So this one was a little different. First of all, because it's a fraction, and we had to be careful with that undefined location. But also, we're not necessarily going to graph it because one of the equations is not a line, like we've been seeing so far. But it's still an applicable problem where we can take an absolute value type equation and break it down into piecewise equations or little functions. Okay, so it's still something that we should be aware of. All right, we're going to stop there for today. For the time remaining, I suggest trying some of the problems from the homework. There's only 3 of them because I know these can be lengthy. Okay, but it's a good practice of this sign analysis and number line process. Okay, we'll start the next section on Tuesday after you guys enjoy your long weekend.